0.342 of landing heads. What is the probability it takes 3 flips for the first heads to occur? So in other words, if we write out those options, it means tails, tails, heads, right? It takes 3 flips for the first head to occur. That means it happens on the third one. So this is actually geometric, but you could use the binomial formula too. It should come out to be the same thing. A geometric distribution is when you have a yes or no outcome, and you keep going until you reach a certain outcome, like heads in this case. But it also works for binomial. Since I think this is under the binomial questions header, let's just use that formula. So this is the formula for calculating the probability of some. Oh no, I think this is for the geometric distribution because they don't have the other part over here. Either way, you probably don't care about whether it's binomial or geometric. You just want to know how to get the answer. Q is the probability that your event does not happen. P is the probability that your event does happen. So the probability that we get heads is 0.342. So that goes in for P. And the probability that we get tails would be 1 minus 0.342, right? Because it's either one or the other. So we take that away from 100%. So 1 minus 0.342 gives us 0.658. Sorry, those aren't in line, but we need to multiply those. And then we have an exponent because it's k minus 1. So k is the number of times it takes to run the experiment until you get what you want. So 3 minus 1 up here. So in other words, it's 0.658 to the second power times 0.342. So 0.658 to the second power means you multiply it by itself. And then times 0.342, so that's a 0.148 probability until we get to the first heads. I don't know how many decimals they want.